Hey guys, welcome back. This is 6-3 Day 1 Tests for Parallelograms. So we're going to be looking at four conditions or theorems that will give us enough information to prove that a shape is indeed a parallelogram. The first one has to do with if you know both pairs of opposite sides of a quadrilateral are congruent, that is enough to be able to prove that this shape is indeed a parallelogram. So for instance, if we knew that AB is congruent to DC and AD is congruent to BC, that would give us enough information to be able to prove that these are actually, or this shape is actually a parallelogram. The next theorem has to do with the angles. So it says if both pairs of opposite angles of a quadrilateral are congruent, then it is indeed a parallelogram. So for this one, we have that angle C and angle A are congruent, and we would have that angle D and angle B being congruent. So just like in the previous one, all two pairs of opposite sides. This one is two pairs of opposite angles. The next one has to do with the diagonals. So if we were to see that if I were to cut this line with the diagonal of this line, and it turns out that we get that those are bisecting each other. Bisect again is to cut into half. That would be enough to be able to say that this is indeed a parallelogram. The next one, or the last one here, is really only considering one pair of opposite sides, and we can see here that if we knew that this side here and this side here were parallel, that's what those little triangles mean, and if we knew that this side was congruent, that is enough to prove that the shape is actually parallelogram. Okay, so now we're going to be looking at being able to justify which of those four allows us to make this statement. So in this case, I'm given sides, and this would be yes, because I have two sets of opposite sides are congruent. Alright, the next one, which method would prove that this is a parallelogram? So again, the red triangles mean that they are parallel, and they are given the same measure of 15, so it would be letter D. Mechanics, scissor lifts, like the platform lift, are commonly applied to tools intended to lift heavy items. In the diagram, we have that angle C and angle A are congruent. We also have that angle B and angle D are congruent. So we want to know, explain why consecutive angles will always be supplementary regardless of the height. So think about if we were to make this scissor lift go down, and we want to kind of see what would happen if we change this original shape so that it eventually becomes almost compact. These angles are going to remain in the same relationship, so they will always be supplementary. So no matter how flat we get this. So in the next example, we have shows a car jack used to raise a car. So just like in the last one, if you're using a jack, it might start off to be really flat, and then as you increase the height, the angle relationships remain the same. So let's see what we're given. AD and BC are congruent, and AB and DC are congruent. So what this means is if we can prove that the opposite sides are congruent, then we can prove that this is parallelogram. So we are only given sides here, so the only thing that is going to make sense is to use letter C. Alright, we're going to use some algebra skills here to solve problems. So show that this is a parallelogram. If that's true, we want to say that 4x minus 1 to 3 times x plus 2. Remember, this is a distributive property here, so we'd have to distribute. We'll get 4x minus 1 is equal to 3x plus 6. If we were to solve that equation for x, subtract 3 from both sides, and add the 1, we get x is equal to 7. The same thing will be true about these other sides here. 3 parentheses y plus 1 is going to be the same thing as 4y minus 2. Use your distributive property. We would subtract 3 from both sides, and we would get y, and then add 2, and we would get y is equal to 5. So I'd like you to possibly try this one. Press pause, and then we'll work through it. Okay, so we know that this is indeed parallel. We just need to find the m value that makes this sentence true. So if I subtract 3m from both sides, I get m plus 2 is equal to 8. Then we subtract our 2 from both sides, and we get m is equal to 6. Alright, so here is, so in coordinate geometry, we were going to determine whether the quadrilateral is a parallelogram and justify your answer by using this slope formula. So in this case, if we could just prove that both sides are parallel, that will be enough to prove that they are indeed, or it is indeed a parallelogram. So if we look at this slope here, I get a 2 and a 4. So the slope right there is 2 over 4, which is the same as 1 over 2. If I look at this slope here, and it is negative if we really want to pay attention to that, the rise here is 1, the run is 2, again negative. So we can guarantee that that is actually parallel. And then we look at this next one. See, the rise is 1, 2, 3 over 1. And wait, 1, 2, 3. It's actually 4. 4 over 1. And then we look at this one, and that is also 4 over 1. So since both pairs of opposite sides are congruent, therefore this is a parallelogram. Okay, we'll look at the next one here. I've sketched in those. Determine whether it is indeed a parallelogram. Again, we would have to check our slopes to see if they actually have the same slope. So let's check this one here. So if I look at that one, I have a rise of 2, a run of 4, 2 and 4. And we check this one, and this one appears to have a rise of 3 and a run of 4. So this is not a parallelogram. Okay.